Hi everyone, it's Francis McInerney, Managing Director at Future Creators. And as you know, Future Creators is our comprehensive system for managing at zettabyte scale. And today I'm going to show you something very, very big. As you know from our seminar series, that we have analyzed the cloud and we've divided the cloud into three membranes. And there are already tutorials on the App Membrane and the App Enablement Membrane. Here we are going to look at the third and final part, the App Delivery Membrane. Now, this piece is big because it will force the complete shakeup of the $2 trillion global telecom business. I'm going to take you through this step by step. The numbers are enormous, and the impact on every person and every organization on this planet will be overwhelming over the next 30 to 40 years. You'll learn something today that I think will turn everything you ever thought about the basics of telecommunications and your role in it, because if you have a smartphone, you have a role in it on its head. The conventional wisdom in telecommunications networks, and I've been in that business for 40 years, so I know it's pretty straightforward. Whoever offers more bandwidth wins. That's it. You offer more, you win. The Future Creators insight is not this at all. The Future Creators insight, because everything we say about future creation is based on cloud dynamics, which we understand very well. The cloud forces capital efficiency on everything it touches. If you have something that is not capital efficient and it touches the cloud, you've got a big problem. And you've seen our video tutorial on Apple, and you know how Apple stayed out of the app delivery membrane, and it's because of this. Now, the cloud requires, therefore, a new and highly capital efficient app delivery architecture. That is the basic architecture that connects the apps, like the apps on your smartphone, to the app delivery, the app enablement device, which is a smartphone itself. So the smartphone enables the apps are on the cloud, and the app delivery architecture connects the two. So it's a vital piece. The problem is straightforward. Common carriers worldwide have terrible debt equity ratios, and their property, plant, and equipment ratios are also awful, way, way, way out of line. There is no way any of these companies is in a position to replace the legacy network with what the cloud requires. These companies, and you know who they are, it's Verizon, AT&T, NTT, KDD, all of these firms, they have no way of reaching their capital efficiency survival numbers as they are now structured. And interestingly, if you look carefully enough, you will notice that all growth for the last 25 years has not been based on the legacy network, but on shared assets. Cell towers, they're shared. Take Crown Castle, started in 1994, building a highly capital efficient shared asset structure. Data centers, Equinix. Again, very capital efficient. Fiber backhaul. Look at how fiber backhaul is managed today. It's shared. It's not all owned by one company. Wi-Fi. Well, Wi-Fi has got to be about as capital efficient as it gets. And app enablement devices. We all own our own smartphones, our own cars. The capital efficiency is there for the taking. Now, what this means is the 1877 model on which telephone companies and even cable companies are based is long dead. It's been dead for 25 years. We now have to face the consequences of what happens when the powerful inflationary forces of the cloud hit what's left of the network and shred it. Legacy carriers cannot be future creators. It's as simple as that. Legacy carriers, your mission is not to run after newfangled ideas like fifth generation cellular, so-called 5G. Forget it. Your mission is a complete restructuring of your organization first. This means we have a $2 trillion global market that must be completely restructured. Now, let me reiterate a few things about the cloud. We have our tutorials in detail on all of this, but let me reiterate. First of all, clouds give the remotest person or thing access to unlimited computing power, and this is the key at marginal cost. Marginal cost computing, and it doesn't matter whether we move to quantum computing, DNA computing, it doesn't matter what the computing power is, our access is at marginal cost. Every time you pick up a smartphone, you're getting access to powerful cloud-based systems at marginal cost. This is way more revolutionary than the printing press of 1440, and that unleashed the Reformation and the modern corporation, amongst other things, and our entire legal system. All of our government operations are democracies and how they run. So let's move on to the next stage. Cloud inflation also unleashes information surface inflation. In other words, if you have an inflating cloud and you're a company like an Apple or a Google, the surface, if you like, that you have with which you can touch your customers inflates at a commensurate level. So the simpler way to do this is to take my 1996 chart with the Moore curve on the left. You can see the arrow pointing to it. The number of devices unleashed on the right. This is key. You can see the number of devices unleashed as price performance on the Moore curve improves is phenomenal. The size of an information surface available to a company is the left times the right in the simplest way of looking at it. And what you get is an information surface. Now, we've had the kilobyte era, the megabyte era, the gigabyte era, and of course, a couple of other eras before we get to the now cloud inflating zettabyte era. It is natural for the legacy carriers to want to support this inflating surface. This is where they connect to their customers, and this is what they do. I should say did, because many of you are aware that you connect through Wi-Fi today, and that significantly diminishes the role of a common carrier in terms of the traffic it gets and how it manages that traffic and what it can do with it. The problem is that the legacy carriers have a capital efficient structure that dates from 1877, 140 years ago. So it long predates our kilobyte era on this chart. The app delivery membrane, by contrast, must be capital efficient enough to inflate as fast as the information surface, and this is a monster stress. When you have a terrible debt equity ratio and horrible property, plant, and equipment ratios, how can you ever have something that inflates as fast as the information surface and as capital efficiently as required? You can't. So let's remember now our three membranes and how they work. There's the app membrane, which sits on the cloud, and this is a function of the app equivalency rule, and we have that in great detail in our tutorials, so I won't review that now. Equally, we have the App Enablement Membrane, which is a function of the App Enablement Rule, and we have tutorials on that as well. And today, we are looking at the App Delivery Membrane, which is a function of what you will see is the App Delivery Architecture. That's our basic set of rules for this membrane. Now, these cloud membranes have no limits, though they are not infinite. They can intersect with one another in any combination and re-intersect in any combination. And as we will see, this is where the money is. They have no predefined shape. It doesn't matter whether when you're talking about an app enablement device or an app, whether you're talking about a car, an airplane, a coal mine, shale well, or of course, a cell phone. This doesn't matter. Now, these membranes must inflate with the cloud itself. So, the cloud inflation stresses that apply to the app and app enablement membrane apply also to the app delivery membrane, to the network. The rules in one membrane cannot contradict those of another. This means the app delivery membrane must respond to the other two, like it or not. Now, key, capital efficiency drives all three. You will see the app and the app enablement membranes have been thoroughly converted to capital efficient models. The app delivery membrane has been partially converted since the advent of cellular and shared cell towers. The next step will be way bigger, more massive, and a much bigger shakeout. Let's understand too what is at stake here for people who are running businesses. Cloud inflation is unlimited opportunity. The rate of cloud inflation is the exponential growth in the number of devices times the exponential growth in device power on the Moore memory density curves times the exponential growth in the number of power of apps. There's money in this. So you have the cloud today, cloud tomorrow, cloud in 2100, and the app delivery membrane must support this. This is a long timeline we're talking about here, and the app delivery membrane must be able to support that. Now, this is where business makes its money today, cloud membrane interaction. We have the three membranes, the app enablement, and the app delivery membrane. And what we have, just look at Apple, is a monetizable cloud membrane interaction envelope. And it's going to grow with the rate of cloud inflation. This is where the money is. So, the cloud membranes expand at the rate of cloud inflation. The cloud membranes always interact. The membrane interaction envelope is monetizable. Apple sure has demonstrated that one. The monetizable interaction envelope is growing at the rate of cloud inflation, and successful business models expand their information surfaces to the cloud-inflated membrane interaction envelope. That's what they do. They identify the most profitable interactions, and they design everything back from those most profitable membrane interactions. Apple got this. No one else did at the time, that's for sure. So, your information surface must inflate from here to here. That's what you have to do when you're running a company. Legacy networks, however, are not capital efficient enough to make this work for you. Simple as that. They don't have the financial structure to do this job. This is way too much stress on their operations. They cannot get here from where they are now. So let's think of this in a little more detail. I've turned the chart, my information service chart, on its side. You have the kilobyte era back in the 1960s. And in those days, you didn't have too many points of presence because in the kilobyte era, you had IBM mainframes and maybe a few 100,000 terminals. So information service was really small. We've moved up to the gigabyte era, the terabyte era, and then bang, the cloud exploded. And we had rapid succession, petabyte, exabyte, and now zettabyte eras. And during this period, an enormous expansion in the information surface that is available to business to monetize. Now, the cloud inflating information surface must be capital efficient. That's the only way it can work. No carrier has the capital to build end-to-end networks at this scale. They just don't. Shared ownership is required. As I mentioned, cell towers, data centers, fiber backhaul. Shared ownership is the key. Cell towers, fiber backhaul, or widely distributed like Wi-Fi. Now, what we have, therefore, is the capital inefficient 140-year-long telco era being replaced by the capital-efficient shared or distributed ownership era. Everything you hear about technology today sits on this one slide. It doesn't matter about all of the technology you hear about, this generation, that generation. It's the capital structure of the companies involved that will shape the future. So, we have come up with an app delivery architecture. And we first came upon this concept in 1995, so it's been with us for a while. This is a new era of capital efficiency that supports cloud-inflated information surfaces. Now, let's look at some basic rules. We have to deliver unlimited computing power to an unknown number of devices at marginal cost. And here you have the slide on information surface inflation. This is an unending shift, unknowable power, huge bandwidth demand, unlimited applications, and really you have to have a 30-year lifespan for a half-decent return on investment. Okay, what about what it has to do? It has to support cloud inflation on all media, wireless, wireline, it just doesn't matter. To do this, the app delivery architecture must be capital efficient, but it also has to be energy efficient, which we'll discuss in a minute. And it has to support increasingly complex structures and business models. And if it can't do that, it's a waste of time. It must support increasingly dense networks, and we'll see that in a second as well. The simple way to do it, though, is to think of a Mac Mini content delivery network server on every telephone pole. You begin to understand what's involved here. It must be application indifferent because on the cloud, anything could be key. So let's look at these Akamai charts. Here we have one dated, I think, 2009, and here we have the most recent one. And you can see the enormous increase in bandwidth demand, and they've got a few different people's models here. They got one from Cisco, and then they've got Tom, and he's the head of investor relations there, and his model, of course, is gigantic. And you can see this is over, well, not quite 10 years, from 09 to 17. And the load differences are gigantic no matter which way you look at it. So we have another big question, which is cost. This new network has to have an order of magnitude lower cost than existing networks. Here you have carrier average revenue per user, ARPU, and you have carrier costs per subscriber. And we have an indifference curve running between the two. The app delivery architecture sweet spot is where carrier ARPU goes up and costs go down. The problem is that the legacy carriers are headed here, the bottom right. Their costs will go way, way up. And there's no way that they can, under today's circumstances, get more ARPU. They just can't. So they have to end net neutrality so they can get at least above the indifference curve. If they can't end net neutrality, they can't get the revenue from you and me that will allow them to fund this enormously expensive enterprise. It's massive, massive difficulty. So this does not solve the capital efficiency problem. Instead, it forces customers to shrink their information surfaces, and that drives economic decline. So this is utter madness. And the net neutrality feint on the part of the common carriers to get the money so they can build this thing at the expense of business makes no sense. None whatever. It's a big problem driven by capital inefficiency. And all the other arguments you hear about net neutrality mean nothing. It's just this. That's all it is. Here's the chart. It's all you need to know. Now, there's an interesting thing too, which is low power. The fact is, we've got Moore's law on one line But the survival path in terms of power consumption has to be even more radical. Think of Equinix data centers with their new attempt to put special battery technology in those data centers and do some grid arbitrage. Power Oasis, very smart company. We've worked with them. The integration of solar and small cell. If you can make, with the use of solar, lithium-ion batteries, and other things, the app delivery architecture an energy generator, you can make it an energy of grid arbitrage. And you can end our million-year reliance on carbon and make a lot of money. So this new network has a lot of dimensions to it that have to be followed. It must be extremely capital efficient, of course, because that's rule one of cloud inflating information services. But to do it, it must be almost imagine something that's almost self-installing, reducing, even eliminating installation costs. You know, Wi-Fi doesn't cost a lot to install. Let's begin to think of it in those terms. You look out in the street and see all that stuff out there, and you begin to understand the scope of the problem. Verizon, in fact, had to stop its fiber rollout in 2012 when only 1/3 of the homes passed subscribed to what they had put in front of them. And it had already spent $23 billion to get a lousy 1/3 take-up. And its debt equity is an eye-watering 4.9. There is no way these people can go forward. They cannot afford app delivery architecture without being restructured end to end into a new complicated shared asset structure, which might make this thing efficient. So end-to-end restructuring is mandatory. Now, here is where things get really interesting. And I want you to look at this carefully, because when you think of your business requirements, and you think of what you need, and then you look at this map, it shows you just how complicated it will be to deliver for you, but it must be delivered. First of all, this is from Akamai. They defined what they call the core problem some time ago, which is that the core gets congested with cloud data centers. Well, we had figured that out in 1995, and we had a very interesting solution, which is creating a distributed network. So you had distributed content delivery network servers in an app delivery architecture. So that was our 1995 view of how the network would have to look to carry the loads. You can see Akamai's 2017 implementation in this chart. It's really dense. All those little yellow dots, little yellow-orange dots, are in effect Akamai servers or distributed servers. This is amazing when you think of it, and what it implies is it's extraordinarily dense. This density requires connection, and that's the app delivery architecture. But the capital inefficient telcos cannot make this work. They do not have the money. There is no way it can ever happen with them. Now, this means that we have a legacy network shape changer. What a lot of people do not know is that common carrier revenues in the United States, for example, are declining during a boom. The boom started in 2009 and continues. So, you have carrier revenues declining during a boom. This is unprecedented and a very bad sign. The last decline was 1935, several years into the Great Depression. Carrier revenues falling in a boom, unheard of, and they're falling now. So if you go back to that original chart that I had, I shouldn't say original, but earlier chart with the indifference line on it between ARPU and costs, the carriers are being forced down the ARPU curve real fast. And they're being faced with these costs. This doesn't work. There's no way this can be done. Common carrier balance sheets and PP&E ratios will not support growth, as I've said several times. Common carrier business model died about 1990. Let's face it, it died in 1990 and cellular kept it alive. It was saved by cellular for a good 25 years. But today, all of the growth parts of the network, everything that cellular grew, are actually shared and not telco owned. As I mentioned, cell towers like Crown Castle, American Tower, data centers, Equinix, Zayo, fiber backhauls, Zayo and Crown Castle. These are just examples of how in the last 25 years, all the growth elements of the cellular network that kept the carriers alive have not been owned by the carriers. So this was great, except that they didn't get the money. They didn't get a revenue from this. This is not a revenue source for them. This is a revenue source for Crown, Equinix, Zayo, and so on. So there have been some massive shifts. And finally, the big one is, of course, Wi-Fi. Wi-Fi is extremely capital efficient. It's shared sometimes, sole owned the other times, but whatever, it's extremely capital efficient. So the app delivery architecture is a global shape changer. The size and rollout speed required mean unprecedented levels of capital efficiency. This means restructuring of all legacy carriers worldwide, whether you're Deutsche Telekom, Telefonica, you all must be completely dissolved and rebuilt from scratch. This is a $2 trillion market. This will be disruptive. Uberization on a massive scale. We've already shown how Apple and Google are preparing to Uberize wireless networks. We've shown it, we've demonstrated it, and there it is. Now, the end of legacy carrier means, for the rest of us, an app revolution, an app enablement device revolution. These are gigantic new markets with many more Apples, Googles, Facebooks, etc. This is huge. And then there are the grid arbitrage revenue opportunities, which will be monstrous. No one can stay away from that. The chance to make money from energy is just exceptional. So we say, long live the app delivery architecture revolution. There are key lessons. To be future creators, ADA operators must be capital efficient, like Crown Castle, not like Verizon. To keep scaling with other cloud membranes, ADA operators must constantly innovate in capital efficiency. That's the key of the innovation. You know, if you're a Crown or a Zayo, your future is about capital efficiency innovation more than any other thing. You have to ensure that your customers have the biggest monetizable information surfaces. That's what you've got to do for them. That's where the money is. That's where the money is. To participate, if they can, legacy carriers must be restructured end to end, broken up, rebuilt, rethought. You know, what's happening to GE today is nothing. These companies are enormous. Their asset bases are immense, far-reaching. This will be a big, big restructuring. The carrier net neutrality agenda, as I've said, is to get customers to fund their inefficient, capital inefficient legacy networks in any growth they can manage. It's to get you to support an 1877 era vertical integration against capital efficient app delivery architecture. So for extra guidance, we've got our foundation series. You've seen the Cloud Inflation in You video, the App Membrane video, and the App Enablement Membrane video, which tie into this directly. How to manage your information surface, which ties into this directly, of course. Information surface monetization, key to this. And we have case studies. We have Ericsson. Important to put in some of the companies that supply the hardware and software that make all of this stuff work, because most of them are in deep trouble. And largely it's because they do not understand what's going on and are selling into these capital inefficient customers, and they're supposed to be surprised by what's happened to them. The ALU Nokia deal, which I've always said is dead on arrival and is proving so every day. Cisco, very interesting player, always worth tracking what Cisco does. So I've been future creating since 1976. I've seen the good, the bad, and I've seen the very, very ugly. We do not want you to be in the very, very ugly place. We want you to be a future creator. And I will see you again soon, and we can keep you on that future creating path. Okay, thanks now. Bye.